So in the previous videos, we implemented the most of the chess rules, and in this video I'm going to implement being able to remove a piece from the other player. So let's implement that. Okay, so here is valid movement position, and we will need to provide also the player that is using this. In the case we are going to remove the other players in the case we are going to remove a piece from the other player. So if this is an empty cell, it is an empty cell, or this position is a chess cell piece, and this. Actually, let's simplify this. Let's add methods to this interface to check if this is empty. And to get the kind of the piece that can be null in this case. And the same for the player. So now it should be much easier for us to use this code, because now we can do is empty, and we can check this position player is different than the player. So this junction. So here so is valid movement position. Maybe the player, we can get it from the old position, maybe. So this old position player, and here we are going to provide the old position, that is valid movement, and let's refactor this function. Change signature. Let's change this and put the position before. So now it's the position to the new position. Let's rename this. Old position, new position, and here new position. The same. And probably no, it's okay. So this is empty, or a different player. Actually, this should be enough in this case, I guess. But this is still not working because so in the case this is this is not empty, that should be the last movement. So we cannot remove the piece from the other. Okay, so this looks fine, more or less, because a movement shouldn't allow to keep your king in a dead position. So for example, here this shouldn't be a valid position, and all these shouldn't be valid position, only this should be a valid position. That is a position where the board doesn't have the king in a dead position. So let me think. We are going to implement instead of doing the movement here and in a mutable way, we are going to keep the board immutable. So this is not going to happen. This is not going to happen, so we have to set the array, and we are not going to expose the array. So the thing is that with movement, we are going to create a function that is going to be with movement, with the old position and the new position. And this is going to return a new chessboard, because this is not going to be mutated. We are not going to allow that. So the chessboard, we are going to clone this chessboard. We are going to have a method to clone it. Or actually, no, it's not required. Let's create, let's clone the array. Something like this, and then we are going to implement this here. This is the new array, the old position, and the new position, and we are going to use something like this. And this is not allowed because array2 doesn't have this extension methods. So let's create this here. And set value t. Something like this, and we are going to move this to an array2x. So here we are, cell with movement. So this is going to, let's test this. Test movement. And we are starting with a default board. We are going to move the position 1, 1 to the position 1, 2, for example, point int. And this is going to be this, I guess. This is not going to work with movement. With cell pose and cell chess cell. So pose what a cell, and we can actually do something like this with cell at this. It's going to have this piece, and we can do the same for the other. Something like this. Now, since this is now immutable, we will have to change this container. So now we should probably make this mutable. The variable, and now we should probably also let's create an each method with x, y, and the value that is going to be the cell line, and let's use the array each callback. This actually this should be internal published API. And unit. So this is the callback. We are redirecting it without exposing it, and here we are going to mutate the board with a movement that is going to be the piece pose with a new position. In the case it is a valid movement, and this should work the same. It is the case. But now that this is immutable, we can actually verify when we are getting the available movements. We should be able to get available boards, or maybe getting the available boards. We can get the positions, and we can actually simulate the boards here, and we can determine, we can figure out if a board is a mate, if it's a checkmate. Here, and how we can do that? We can do that by iterating all the pieces of each player and checking if one of the movements is the king, is the piece of the king of the other player. So check is it's called check it's check. Okay, check. So check is check, but we are going to implement that in the next video because we are running out of time.